I'm really excited to be here. I've wanted to talk about Apple TV, well, forever, and I'm so excited that they finally brought it out for developers. So yes, I'm Sally Shepard. I'm Mostgood on Twitter, if you want to tweet at me. I'm mainly an iOS developer, and I also do some side projects working on fitness trackers for cats. So not very related, but very fun. So I'm going to start with a brief introduction about what the Apple TV is, the hardware, and also tvOS, the software that runs on it. So what is the Apple TV? I mean, out of curiosity, how many of you are iOS developers? Yes! The rest of you, get on it. So yeah, for anybody who doesn't know about the Apple TV, the fourth generation was announced in September, but this is the first time we've actually had access to writing software for it directly. So what kind of stuff can this little box do? Let's take a look at some of the specs. So it's a 64-bit A8 processor. It's got 2 gigs of RAM, Ethernet, Wi-Fi, Bluetooth, all the fun stuff, and you can get it in 32 gigabytes or 64. And it's about 10 square centimeters, so it is very little. And it comes with a very fancy remote with a glass touchscreen. And this is a brief comparison about kind of the fourth gen Apple TV against some consoles and some other media players. So it's definitely not as kind of souped up as a console, but it's just as good, if not better, than the other media players. So it's capable of doing some pretty awesome stuff. tvOS is the OS that runs on it, and it provides access to lots of different frameworks. So if you've done iOS or Mac, you're probably familiar with most of them already. You can write in Objective-C or Swift. And they've also added some special frameworks just for tvOS in JavaScript and a markup language so that you can make these really lightweight, template-driven apps. And Apple really pioneered a lot in the way of touch interfaces. So how have they actually carried that over to the TV? Well, it comes with this really cool remote. You've got the glass touch surface, so it actually recognizes gestures. You can swipe and tap and press on it. The menu button usually serves kind of 2 functions. So either it will take you back to the previous screen in kind of a navigation hierarchy, or if it's in a game, it will generally pause the game and then give you some contextual options. The home button takes you home. The Siri button, in countries that support it, which isn't very many at the moment, you basically can ask it to show you, like, show me all the James Bond films, or show me what's good to play for the kids and stuff like that. And then you've got the play and pause button, so generally for controlling playback of media, but you can also access this. So if you had like an image that represented like a photo album and you press that, it could kind of start going through the photos on its own. And then it also, this is one of my favorite things, is the volume up and down button. So it, which I know sounds really lame, but it supports, the Apple TV supports HDMI CEC. So it actually controls the volume on your TV. It's amazing. You only need one remote. And if your television doesn't support HDMI CEC, you can also pair it via infrared, so you can still use it. And what's not on the slide, but the remote also has, is an accelerometer and gyroscope, which you can leverage. And there's also third-party controllers you can get. So this is the very popular SteelSeries Nimbus controller, which is great for gaming. I think Guitar Hero is coming. There's a special Apple TV version of Guitar Hero, and Disney Infinity is launching something as well. But anything that's kind of made for iPhone or iPad will work with the Apple TV. And when you're developing apps for the Apple TV, you'll probably end up using the simulator at one point in time, because it's a lot faster than trying to build onto hardware every time. So there's a software version of the Apple TV remote, and you use it kind of in combination with the keyboard as well. So if you want to navigate through the items on the screen, you can use the arrow keys on your keyboard, And if you hold down the Option key, you can kind of mimic swiping and tapping and all sorts of fun things. So if your background is solely on mobile devices, where interaction is driven through touchscreens, you'll probably have to modify some of the way that you approach design. And the biggest difference is how people experience TV. On mobile and web, we pretty much design things to be a very exclusive kind of single user experience. We only worry about what that one person wants to do. They're very much in control of what's happening. And in these situations, we show them information that's very particular to them and very personal. But if you're with lots of other people, you need to be careful not to show like bank details, or you probably don't want your text messages showing up on the TV. So it's important to think about the context that other people are probably going to be around. And another important difference is distance. You probably can't read the text, which is on purpose. But people could be anywhere from 1 to 4 meters away from their TV. So don't use impossibly small text. You know, TV is this very cinematic, dynamic experience, and you should really try to play that up even in your apps. But don't needlessly fill the screen with millions of elements. You should provide really clear, concise layouts with very shallow navigation hierarchies. With web, we tend to put lots on the screen, right? Like, users can use a cursor, so precision is fine. And then when we go onto mobile, we have to simplify it. We have to make elements bigger. We have to put space around them so that users still have that precision, even in a touchscreen. And then on the TV, we actually simplify it another level. So we make things very grid layout. We try to group things up, so to speed up navigation. And we've really gone to this very simple approach from web. Another thing to test is the color. So when you build it, especially on your computer, the color will probably look fine and great, and then you run it on a TV, and it probably looks a bit scary. So it's really important to test it on different TVs, and try to test it in different color profiles as well on your TV, if it supports it. And they've opened up test flight distribution, so you can actually get beta testers for your Apple TV apps. So make sure that it doesn't look weird on other people's TVs. There's also, sadly, this thing called Overscan. And this is kind of a legacy from old CRT displays, where it would trim the edges of the picture and scale it up. And kind of modern TVs still support this, so that old content doesn't look bad. But just make sure that you always kind of have some padding on the edge. You know, don't put anything too important on the sides or the bottom. So I'm not going to go through everything about design, because there is a lot. But if you're interested in it, or if you're going to do an Apple TV app, please, please, please read the Human Interface Guidelines on TV. It's a really, really well-written document, and it will save you lots and lots of time. Right. So how do we make a tvOS app? Well, let's look at what's available. There's two main ways to approach it. There's the client server, and there's the traditional approach. So tvOS provides two ways to use what Apple have called the TVML, Television Markup Language, and the TVJS classes to show content from network resources. TVML kit calls to a server-based JavaScript file, which provides content in the TVML. And then this file includes data, assets, media, and anything else that it needs on the server. And the returned files are rendered through templates, and all the user interaction is handled through the JavaScript file. You can add UIKit code or anything else you want. But if you want to pursue it more, there's some really great sample code called, surprise, surprise, TVML catalog. And it shows you all the different templates and what it can do. So for the more traditional approach, you can use UIKit, which is probably what most people are using on iOS. You can use things like Metal and OpenGLS, or if you want to do 2D gaming, SpriteKit, or for 3D games, SceneKit. But not everything's quite available on tvOS yet. So let's have a look at what is. So these are all the ones that are available, which is a lot. And the one that is missing that everybody seems to want is WebKit. So you can't show web views on the TV. But this is great, because you don't get all these like annoying pop-up ads while you're playing games. And so basically, these are all tvOS-specific versions of these frameworks. So they're not necessarily as full-featured as their equivalents on iOS or Mac. So you just need to check the documentation to see what might be missing. And just as a slightly funny comparison, this is actually what was available as of iPhone OS 2. So much, much less, but we could still do some pretty awesome stuff way back in the day. So it shouldn't stop you. So what if you have an existing iOS app and you want to port it onto the TV? Well, there's two kind of ways you can approach it. You can either start with a new project, a tvOS-specific project, or you can just add a new target to your existing project. When you do a new project and select tvOS, you get to choose between a game, a single view application, or a tabbed application. And then if you add a new target, you get the same three options. If you choose a new project or a target, it totally depends on your project itself. But if the TV one's going to be very, very different from the iOS one, it might be worth doing a separate project. But if they're quite tightly linked, probably a new target is a better way to go. So for the past couple of weeks, I've been working on porting a game called Quictionary to the TV. And Quictionary is like a little word game. You have to guess what the four-letter word is, and then it unlocks a fact. So this is basically the first startup screen. So you guess a word, and it tells you if any of the letters are correct. So we play golf. One of them is right, but we don't know which one. So you have to guess another word, and eventually you can, through process of elimination, you figure out which word is right. And we also have a multiplayer mode of it where it's kind of a turn-based thing. So you guess a word, and then I guess a word, and it goes back and forth for like 3 times, and whoever has the lowest score wins. So when we started porting it, we decided we'll add a new target. And the first step was to make it compile, which was a long step. For Apple, for any Apple-provided frameworks or third-party frameworks, it all has to be built for tvOS. So this means that if you have added a new target, you'll have basically 2 copies of a framework, because one will be for iPhone and one will be for TV. And we were using CocoaPods to manage dependencies, and although CocoaPods supports tvOS, it's still down to whoever writes those libraries and frameworks to add tvOS support. And none of the libraries that we were using had added support for this. So we changed everything over to Git submodules, so to give ourselves a bit more flexibility on actually being able to change the code and keep track of that. So that took about a day on its own. And then we had to do things like enable bitcode. Bitcode is an intermediate representation of a compiled program. So by including bitcode, this allows Apple to re-optimize your app binary without the need to submit a new version of your app. So this was another one of the things that you have to make sure you've done. And after about a day of getting all of our dependencies up and running against tvOS, we had to wrap a lot of code to make sure that it was only compiled under iOS, and some other modifications that only ran under TV. We finally got it to run, which was so exciting. And then this is what happened on first launch. Very, very small, really. But it did work. But the main problem that we had was you couldn't actually interact with anything on the screen, which is kind of a big problem for a game. So basically, like, yeah, you couldn't focus on anything. Swiping did nothing. Like, pressing the button did nothing. So then our next problem was, okay, well, we really need to actually make this a bit more native. We need to spend more time. And tvOS has this thing called the focus engine. And this is what manages and controls the focus on the screen. So it listens for any incoming focus movements from your remote or control. And when an event comes in, it automatically determines where the focus should update and notifies your app. And programmatically, you can ask for focus updates, but you can't set focus or move focus in a certain direction. So UI kit items such as buttons and controls and search bars and table views and collection views will work automatically because they can become focused, returns yes on those. So for example, like a UI button will focus by default, but a UI label won't. But you can make it focus if it actually does something, just by overriding can become focused. So by default, all of these classes in UI view and UI view controller that directly or indirectly control the view or screen conform to the UI focus environment protocol. So if you're doing anything custom, it's really important to implement the protocol to handle the focus for these things too. So the preferred focus view, set needs focus update, update focus if needed, should update focus in context. And you can also do did update focus in context with animator coordinator to have really nice animations happen. And then focus engine and sprite kit, wah wah, is just not supported at all at the moment. Hopefully it will be added. I don't know. I sadly don't work at Apple. But even if they did support it, I don't know quite how it would work. It's a little complicated. So, I mean, it's not just SpriteKit. It doesn't work in SceneKit or Metal or OpenGLAs either. So we basically had to write our own way of handling these events. So to start, we looked at the keyboard for Quictionary, and we kind of based this off some sample code from Apple, and this was the approach that they used in SpriteKit as well. So if you imagine the keyboard, and each key is a key node, basically in the keyboard class, we create an object to store basically for each key where, like, what keys are up, left, right, and down from it. And then in the key node class, we add a variable to track whether or not it's focused, and some behavior on how it should look if it is focused and if it isn't focused. And then when the keyboard class launches, we make sure that we set the focus to the top key. Then we create a class that sits on top of the responder chain. And this captures any input device events and forwards them on to the currently focused key node. And then when the user inputs a touch event on the remote, the Apple TV captures the input into the UI responder chain, forwards it on to the currently focused key node. And the key node then asks its parent, what's the thing to the right of this? It returns the key that's to the right, and then performs the update of the state, which works pretty well. But if you are having any problems where focus isn't working, there's this, why is this view not focusable for debugging, and it will actually tell you why it isn't focused. So in this case, it was returning no from can become focused, although returning yes doesn't actually fix it. So that just gets a whole other load of stuff in the debugger. Another challenge is the app bundle itself is limited to 200 megabytes. So you can only read items from your bundle. You can't actually write to them. To write data, you need to either write it to the temp directory or the cache directory, or store something in NS user defaults. The temp directory, its contents are only actually alive until somebody presses the home button, so not very persistent. And the cache folder basically will be there until the system decides it needs to clear it out. So who knows? NS user defaults is great, but it's only 500 kilobytes. So Apple recommends strongly to use something like iCloud or some other kind of syncing service. And you can also use on-demand resources for an additional 20 gigabytes of data. So with iCloud syncing, there's kind of three options. There's the key value store, which can hold up to 2 megabytes and 1,024 keys. There's CloudKit, private and public, so up to 10 terabytes in public, and private, it depends on how much the user is paying for. You can also store documents, but again, that depends on how much the user is paying for. So on-demand resources are a relatively new thing, and basically the resources are hosted on the App Store and are separate from the app bundle that you download. So the app can request sets of these on-demand resources, and the operating system manages the downloading and storage of them. So in Xcode, you basically create some tags and attach them to the resources. And then when your app requests the resources associated with the tag, it just downloads those assets. There's lots and lots and lots of stuff to on-demand resources, which probably could warrant an entire talk on its own. There's a really great guide on everything you ever needed to know about on-demand resources. So read that if you want to. So we didn't find too many things that we were personally missing from the frameworks, but I've worked with other people who, multi-peer connectivity, for example, isn't a framework that exists. And a simple solution to that is to drop down to a lower level API, and you can use something like NS Net Service. And then for other things, well, you can use some kind of third-party REST APIs. And then it's really important that if there is something that's missing and you can't find a way around it, to file a radar, because that's the only way that Apple will fix things. So we also have these parallax images. So basically, there's multiple layers to the image, and as you move around, they move it at slightly different rates to create the effect. And it gives this really great sense of depth and vitality that helps emphasize what's focused on the screen. So if you wanted to make like this really amazing beach emoji scene, because I bet you do, it's very simple. The support is built right into Xcode, so using your design tool of choice, you can create different layers with the emojis and the beach scene, and then bring them into Xcode, and then voila, you have the world's most beautiful beach. And then there's also the top shelf. So basically, users can put up to 5 apps in the top shelf. And then when the app is focused, it shows related content. So you get to define what these things are that it shows. And it's really easy. Surprisingly easy, and not that many people are doing it yet. But basically, you add a top shelf extension. It creates a class that conforms to this TV top shelf provider protocol. And there's 2 things that you specify. One is the top shelf item style. So you can choose between inset or sectioned. And then you provide an array of TV content items. So it has things like a content identifier, some URLs. And then if you've chosen the sectioned style, you also need to provide it like another array. So you kind of have arrays of arrays. And then you choose a shape. So if you have picked the inset style, then you only get the extra wide shape. But if you choose sectioned, you can choose between poster, square, or HDTV. And universal purchase. So this is quite cool that if you have an app on iOS, you can bundle it basically with the TV app. So if they've bought it on iOS, they also get it for free on TV. To do this, all you need to do is make sure it has the same bundle ID. It's really easy to do in iTunes Connect. But once you have actually enabled this, there's no way to disable it. So make sure you've made the right decision. Right, so we've only worked on porting Quictionary for the past couple of weeks. So to wrap up, I wanted to go through a few of the things that we've learned so far. And the first one is around architecture choices. So we definitely need to make things a lot more modular. I think, especially when you're just doing iOS, it seems harmless to just be like, yeah, we'll just do this and we'll fix it later because we'll totally have time. But you end up with this kind of messy code, and if you put lots of this, like, oh, if it's tvOS, do this, if it's iPhone OS, do that, and your class becomes thousands of lines long, and it's just, no, don't do it. And if there's anything that you can kind of take away, like, I mean, thankfully, Quictionary wasn't written so that the keyboard and the game board were all in the same class. Like, the keyboard is its own thing, and, trying to make everything as reusable as possible, because then if you need to swap it out for TV, it's just a lot easier. And once you actually start porting, it was interesting to you start looking at your code and going, yeah, that wasn't a good idea. We really should have split these out a bit better. I think now, kind of going forward, writing iOS apps, it will give me a better perspective on how to approach things. And become a bit more strict about dependencies. Like, I really like CocoaPods, but I do worry a bit about how people just kind of have all these dependencies that they don't really know about. So we got rid of quite a few, and we've now decided to only use ones that support tvOS and iOS. So if you make any frameworks for iOS, make sure that you add support for tvOS. And we have to make a lot of design changes. One thing we've learned is that keyboard layout is not very fun to play with. Keyboards on the Apple TV are generally not very fun. So we've been working on ways to kind of improve the experience around that. So we're trying to kind of put it straight across all the keys, hide the red ones that we know aren't working and stuff like that. But there's still a long way to go on that. And we also need to come up with a more engaging multiplayer experience, because the kind of alternating on the word thing doesn't work so well on the TV. But ultimately, this is just the beginning. This is the snapshot in time. I mean, they call it tvOS 9 because it's an offshoot of iOS 9, but it is still very much the beginning. So more frameworks will get added, but definitely file radars if there's anything that's broken or missing. But it's a totally new frontier. Please don't make any more Fireplace apps. There's already too many of them. But go make something awesome, because it's still like a relatively quiet platform, but people are spending a lot of money on it. Yay, money. So I've got a few resources to finish up with. Basically, if you want to get started with tvOS, the app programming guide for tvOS is really excellent. And the human interface guidelines. The DemoBot sample code is really great. It shows it's a cross-platform game that runs on Mac, iOS, and tvOS. So it shows kind of how to handle a lot of that. There's the TVML sample code, as well as a UIKit sample code that kind of catalogs everything. So thank you very much for listening. If you have any questions, let me know.
Hello, my name is Victor, and I have a few questions. If I understand you right, you already have your app on the tvOS.
It's not in the store.
Oh.
We're still trying to make it
So the first
better.
part of my question was about, do you see some impact on your user base? Will users migrated to tvOS or not, but
Yeah, I have friends who've done tvOS versions of their app and have seen huge increases in downloads.
And second part of my question is how much time you spend to prepare tvOS version of your app?
So we spent about a day just making it compile on its lowest level, and then we've spent probably another few days just trying to get the design bits to work. The focus engine stuff was, that took about a day as well. So probably, it's been a few weeks. So I think we probably have another few weeks to go before we're ready to test, and then another few weeks to submit probably.
Thank you.
Thanks.
Еще есть вопросы?
Are there any more questions?
Пока Оля ходит с микрофоном, я
Well,
рекомендую
Olga is
Салли как
around
большого
with a
специалиста.
mic. Sally is a great specialist in the realm of Internet of Things.
Cats and the Internet of Things. Yeah. Only cats, though.
Hello.
Hello.
Thank you for your presentation. I have a question. Did you have a chance to test it on real device?
Yes. Yep.
And how you organized it?
So I got the developer. Apple was really awesome and actually sent out developer hardware for the first time in like forever. So I got an Apple TV for £1, which is great value. It's great value at its normal price, but it's tremendously good value at £1. But it connects via USB-C to your computer, and you can basically just select that as a device and run it straight from your computer. Yeah. Any other questions? No?
I'm sorry, please replace all the questions in the halls, okay? You can find Sally here.
Yep.
Thank you a lot.
Cool. Thank you.